Okay, my fancy microphone with the batteries are dead, so the sound might not be quite as good on this recording. We'll finish up what we started talking about yesterday. So go ahead and click close for me, please. Let's have a little look here. So we were talking about solving absolute value equations, right? And where we left off, we had done a bunch of examples with numbers. Right? What was our strategy with numbers here? Like if we were given this absolute value equation up here, 3 times the absolute value of 2x minus 1 equals negative 7. Okay, what do we do to solve that? What do we try to do first? Good, we're going to isolate the absolute value, right? So we're going to add 1 and divide by 3 to get the absolute value by itself. Once I get the absolute value by itself, well, this was a bad example because this is one that was impossible because I had the output of an absolute value equaling negative 2. But if I go back a little bit, like to here, for example, we isolated the absolute value. The absolute value of 4x minus 20 equals some positive number. Then what? Right. This is the step where we're going to trade the absolute value equation for 2 non-absolute value equations. Right? Remember what the pattern is. Whatever's inside the absolute value bars, we're going to set equal to the number or its opposite. And then we just solve both of those to get the 2 values of x. Okay, make sense? Okay, no big deal. If we have a number outside, that's pretty quick and easy to do, right? But we started looking at an example yesterday where we had variables outside also. It's okay, we just follow the same rules as before though. We isolate the absolute value on one side, which is already done, right? So once it's isolated, then whatever's inside the absolute value, so what's in green, is going to equal either what's outside, which is purple, or it's going to equal the opposite of what's outside. So negative the entire quantity, the expression what's outside, right? Does that make sense? Are we good with that, with the pattern we're following? Okay, so now we got 2 different equations to solve. Let's focus on this equation first. So we just started this, right? We're going to subtract 12x from both sides. So we get negative 14 equals 2x plus 4. If we keep going, what are my 2 steps in order to isolate x? Everybody just say it. It's fine. Subtract 4 and then divide by 2. Okay, good. So if we subtract 4, negative 18 equals 2x. So one solution is x equals negative 9, right? Okay, now we got to work on the other one. So over here, I'd have to distribute the x. Here, I'll just make a line separating the 2. Over here, we'd have to distribute the x. So 12x minus 14 equals negative 14x minus 4. Now I'm going to push the x's to the left this time, right? So we'll add So I'll add 14x, both sides. I get 26x minus 14 equals negative 4. So I add 14 and divide by 26. I get 10, divide by 26. I get x equals 10 over 26, which I could reduce to what? 5 over 13. Yes. Okay, so here's the thing though. Whenever we're solving an absolute value equation where I have variables on both sides like this, I have to always check my solutions because it may turn out that one or even both of those solutions are extraneous, which means they are false. Okay, so the next step is, let's make a note of this. When you're solving absolute value equations with variables on both sides. Oops, no. You must check for extraneous solutions. And remember, extraneous is really just kind of another word for false. Okay? So we have to plug these back into the original equation and see if they work. Okay, so let's try them both. Let's try x equals -9. If I evaluate the original expression for x equals -9, what do I get? I get the absolute value of 12 times -9, so that's -108 minus 14 is what? -122? Absolute value of negative, you guys check me, did I do that right? Okay, is equal to 4 times -9. Well, it's not going to work, is it? It's not going to work. 4 times -9 is -126 plus 4 is -122. That's false, isn't it? The absolute value of -122 is not -122. Okay, so in other words, that's a non-solution. We can't include that one. That didn't work. Let's try the other one. If we try the solution 5/13. Oh my goodness, really? That's kind of an ugly one to try, isn't it? Okay, so we try 5/13. I'm going to get 12 times 5 is 60/13 minus 14. Oh my goodness, really? Here, I'll tell you what, just to keep things a little bit simpler here, I'm going to go ahead and I'm going to cheat a little bit with Desmos. Here I can justify this. This is a good way good use of Desmos. So here's what you can do in Desmos. It can be scientific or graphing. Good little trick. So I'm going to identify a function. I'm going to set up f of x, and I'm going to set it equal to the left side. This is a great trick, so pay close attention to this. F of x equals the absolute value of 12x minus 14. Okay? I'm going to identify the right side of the equation. I'm going to call that g of x, different function. Super good trick for checking stuff like this. 14x plus 4. Okay? So now I just want to evaluate, I'm going to plug values into the left side and the right side and see if I get the same answers. Well, we already tried -9. Let's just show that that didn't work. F of -9 gave us an answer of positive 122, right? G of -9 gave us an answer of negative 122. So we know that -9 is not a solution. Does everybody see that? I got a different value when I plugged it into the function defined by the left side than I did when I plugged it into the function defined by the right side. Okay? Let's do the same thing now for, what was it? I can't remember what the 5/13. Okay, so we'll try this for 5/13. Let's get this over there so we can see it. So f of 5/13 is that. Okay, now notice it gives me, when it gives me the little convert to fraction button, I can press that and it gives me a fraction. Okay, it gives me an exact answer. G of 5/13 gives me the same answer. So is 5/13 a solution? There you go. Good. Okay, I'm going to take a picture of this and add it to our notes. Make a new page. Oops. So there's a little reminder in the notes of how we did that. So we found that yes, 5/13 is a solution, but no, -9 was not. Okay, give me thumbs on that. Does that make sense? Okay, let's try one more of those. Do I have one more?